Question 5. Immersion heaters. Heating up water. So we're talking about how energy is transferred here. Not from which store it goes to, from where to where, but how that energy is transferred. Is it conduction, is it convection, or is it radiation? Well, the question in this case, the main way the energy is transferred through the copper of the hot water tank. It's going through a solid. If energy is being transferred through a solid, the answer is always conduction. The energy is always conduction. The heater has a thermostat. It controls the temperature of the water. It shuts off at a certain temperature and starts up again when the water drops to a certain temperature as well. So it keeps the temperature within a range of the temperature of the water within a range. So when the temperature of the water, yes, graph A, okay, shows the temperature of the water inside a hot water tank changing with time. The tank is not insulated. That's important. The temperature of the water falls at the fastest rate just after the heater switches off. Why? This is about factors that affect energy transfer, or the rate of energy transfer. What it's getting at here is the temperature differential. The temperature difference between the hot water and the air surrounding the tank. The energy decreases the quickest at that point because the energy differential is at its greatest at that point. So the energy gets transferred the fastest. If the temperature of the hot water was the same as the temperature of the surrounding air, there would be no energy transfer. So the answer is the biggest differential, the biggest temperature difference between the water and the surrounding air at that point results in the energy transfer being the quickest, so the water cools down. As soon as that turns off, it's at 58 degrees, that's when it's going to be at its quickest. It's not going to get any hotter than 58 because the heater switches off at that point. Other factors that can affect the rate of transfer: the thickness of the copper, whether it is insulated or not. In this case it here says it's not insulated. Whether it is double skinned and there is a gap in between the two layers of metal. These are factors you might want to consider if there was a question on insulating your house in terms of factors affecting energy transfer. Pardon me. So, to heat the hot water tank from 50 to 58 degrees, straight away. Why is it telling me, question-wise, why is it telling me that there's a temperature difference? The only equation that you have in energy, or the energy topic to talk about energy temperature difference, is the specific heat capacity equation. All right? Specific heat capacity. Straight away, I'm thinking specific heat capacity. Oh, and it's giving me the energy as well, energy transferred. Key there, though, be careful. It's giving you the energy transferred as 4,032 kilojoules, not joules, kilojoules. So you're going to have to convert to joules before you do anything else. Calculate the mass of the water in the tank. gives you the specific heat capacity of 4,200 joules per kilogram per degree C. So use the specific heat capacity equation, which is that. You will be given it. You do not need to remember it. You will be given that. But you need to know how to use it and what each of the factors are. So the change in energy transferred is 4,032 kilojoules, or 4,032,000 joules. That's important. You need to convert. Is equal to the mass of the water multiplied by 4,200, which is the specific heat capacity of water, multiplied by 8. Why 8? Well, 8 is the temperature difference from 50 to 58. That's why they said it in the question. Don't ignore the clues. If we rearrange, we get mass. You need to convert. Mass is equal to 4,032,000 joules divided by 33,600, which is equal to 4,200 multiplied by 8. Simple bid mass. Work that through, and you get an answer of 120 kilos. 120 kilos is an important number, not because it's 120 kilos, because it just looks right. It looks right. 120 kilos of water in your house in a storage tank. Looks right. Had that number that you've worked out been equal to 3,200 kilograms, what kind of house do you live in that has 3,200 tons of water? Yes? Or if you'd had 0.000 something kilograms, those numbers don't look right. They don't look, sanity check it. Look at it, do the numbers look right? Now if it works at 120 kilograms, yeah, that looks sane, it looks obvious. It's probably going to be right. Check your numbers. So an insulating jacket is fitted to the hot water tank. The graph B shows the temperature decrease and what happens. Starts to heat up again. An insulating jacket only costs £12. 12 quid. By comparing graph A and graph B, explain why fitting an insulating jacket to a hot water tank saves money. Why does it save money? The water stays hotter for longer. The heater is on for less time, so less energy is needed. And if less energy is needed, this costs less. Lower heating bills. It's a simple but extremely effective energy saving device. Water stays hot for longer, less energy needed. Therefore, you use less energy, costs less money.